to another type of problem involving properties of logarithms. They're giving you some values. Natural log of 2 is equal to a, natural log of 3 is b, natural log of 5 is equal to c. Again, they want us to rewrite the logarithms in terms of a, b, and c. Again, you're taking the natural log of a quotient. So using your quotient property of logarithms, I can rewrite this as the natural log of 3 minus the natural log of 5. Well, by the information given, natural log of 3 is equal to b, so I can substitute b in for natural log of 3, minus substituting the c for natural log of 5. So I'm rewriting in terms of a, b, and c. Now, natural log of 18. So look at the numbers they're giving you, 2, 3, and 5. Is there a way I can rewrite 18 as a product using 2, 3, and 5? Well, I know that 3 times 6 is 18. I also know 9 times 2 is 18. So I can rewrite the natural log of 18 is going to be equal to the natural log of the product of 2 times 3 squared, because 2 times 3 squared is 9. So now, using what information they're giving you, I can rewrite this now as a product. Excuse me, using my addition property or product property of logarithms. I can rewrite this as the natural log of 2 plus natural log of 3 squared. Using your power property, I can move the 2 as the coefficient of the natural log. Natural log of 2 plus 2 times the natural log of 3. Natural log of 2, they're telling me, is equal to a, plus 2, natural log of 3 is equal to b. So a plus 2b is your answer. Like I said, anytime you're doing radicals, you want to change them into fractional exponents. So I can write the cube root as the natural log of 75 raised to the 1/3 power. Again, I need to somehow rewrite 75 in terms of 2, 3, and 5. Well, I know that 25 times 3 is 75, and I know 5 squared is 25. So I can rewrite 75 as 3 times 5 squared raised to the 1/3 power. So now, using your power property of logarithms, I can use the 1/3 as the coefficient of the natural log. And then I can expand this out into my, using my multiplication property. So I have 1/3 times the natural log of 3 plus 1/3 times the natural log of 5 squared. Again, I can now use my power property again, multiply 2 times 1/3. So 1/3 times the natural log of 3 plus 1/3 times 2 is 2/3, natural log of 5. And from the information they're giving me, natural log of 3 is equal to b, and then natural log of 5 is equal to c. So now log base of 5 of 3. Again, all of the information given to you is in terms of natural log. Natural log is a base of e. This is a base of 5. So right away, a red flag, I'm going to have to use my change of base formula into natural log. So using my change of base formula, I can rewrite this as the natural log of 3 over natural log of 5 by my change of base formula. Natural log of 3 is equal to b over natural log of 5, which is c. B over c. Last type of problems. Again, these are used a lot in calculus. The directions are saying express y as a function of x. The constant c is a positive number. Well, first of all, let's talk about this part of the directions. When they want you to express y as a function of x, they want you to solve for y. So we want to isolate y. And we're treating c as though it's just some number. So first of all, anytime you're dealing with a logarithmic equation, you want to use any properties of logarithms to condense. I can't condense this right-hand side because there is no natural log in front of the negative 2x. So the only way, the problem is I want to isolate y and get y by itself. So the only way I can isolate y is to do something called exponentiate the equation. What I mean by that is I'm going to raise both sides of the equation to the power of e. Just like you can add and subtract to both sides of the equation, you can take the entire equation and raise it to a power of a different base. Using your inverse property of logarithms, e and natural log are inverses of one another. They will cancel each other out, so I'm going to be left with y equals. On the right-hand side, e to the negative 2x plus natural log of c. Now, all of you are used to using your multiplication property of exponents. Again, you multiply like bases, you add the exponents. One thing now you need to get in the habit of looking at, when you see a plus sign as an exponent, that is the reverse process of what happens when you multiply like bases. So by your exponential rules, I can rewrite the right-hand side as e to the negative 2x times e to the natural log of c. Again, because when you multiply like bases, you're going to add those exponents together. So basically, I just did the reverse process of multiplying like bases. Now, like I just mentioned, e and natural log are inverse properties of one another, so they're going to cancel out. So y is going to be equal to c times e to the negative 2x. Now, when you are also solving log equations, you want to make sure you condense and simplify both sides of the equation as much as you can using all your properties of logarithms. So you want to squish it. I call it squishing. Squish both sides of the equation as much as you can before you attempt to solve for y. So for example, notice right here you have a coefficient in front of the natural log. I'm going to move that to the power of y. So I have the natural log of y squared equal. Move all your powers into position. You have the natural log of x to the negative 1/2 plus the natural log of x squared plus 1 to the 1/3 plus natural log of c. Now I'm going to use my product property of logarithms, and I'm going to condense the right-hand side. So I have the natural log of x to the negative 1/2 times x squared plus 1 to the 1/3 times c. Now again, what I'm going to do is I'm going to exponentiate both sides of the equation. E to the ln will leave me with y squared equals e to the ln is going to leave me with x to the negative 1/2 x squared plus 1 to the 1/3 times c. I'm going to get rid of this negative exponent by moving it to the denominator. So you can do square root of both sides, or you can just raise both sides to the power of 1/2. So y is going to be equal to, remember, power to power you multiply. So I have x squared plus 1 to the 1/6. C is just a constant. C by itself is a constant. C raised to the 1/2 is still not a constant. So I'm just going to write that as c over x to the 1/4. You guys go ahead and try C and D for me.